Good morning, everybody. Thank you for having me along today. Well, I originally obviously came from New Zealand. I grew up in Darfield, a little town that way. As a child, I had dyslexia, as was mentioned earlier on, so I always struggled with education. So I basically used visualization to help my, understanding the world around me. And so that was my background. That led me into basically creating a design agency and called Visualize. And obviously that went so far, and then we obviously had all these amazing emerging technologies coming out. I grew up obviously with the web, and so that led me to set up one of the first digital agencies in New Zealand called One Fat Sheep. And we're doing website development, application development, gamification, transmedia. All these things are becoming quite large now, kind of 10, 12 years later. And one day, basically, one of my 3D producers came to me and said, "Rupert, you've got to check out this amazing new technology. It's called augmented reality." And so he held up his smartphone over a piece of paper, and up popped a 3D house. And I thought, wow, what's that? I've seen that in Minority, I've seen that in Terminator. What is it? And he obviously went on to explain it was called augmented reality. And I thought, this is a huge opportunity to take this technology and do something more effective with it. And so we went to a company called Hell Pizza, and we created the world's first 3D zombie shooter on a pizza box that you can see here. So you bought the pizza box, you scanned it with your phone, up popped a 3D game. So as mentioned earlier on, hugely successful, over $2 million worth of increased sales, 30,000 downloads of the app within 2 months. It was the 8th most downloaded app in New Zealand, above Facebook and above Trade Me in the App Store for 2 weeks. So anytime you can beat the biggest tech companies in New Zealand, it's a good thing. So that basically led to us having a whole range of big brands coming to us globally, Hermes in New York, Red Bull, PwC, throughout the world, saying, look, we want augmented reality. But the problem with augmented reality was it cost a lot of money, it was time consuming, and it was hard to create and hard to manage. Now, I'd seen the same thing with website development and application development, was it already started off bespoke and customized, and then over time it got commoditized by platforms like Weebly, Wix, Squarespace, the WordPress, etc. So off the back of that, I thought there's a massive opportunity to build a platform to solve these problems, and that's where the idea for Platter was born, to create the world's simplest augmented reality creator. So what we've done is we've built a platform where you can come in, you can build your own AR app within 5 minutes, so it's just a drag and drop editor, so that's semi-disruptive within itself. So no longer does it take 3 months and cost $50,000. It's only a couple $1,000s and you can do it all yourself. So that's the first part of it, some work we've done with Saab. The second part is we've got a 3D content creator. And so this is basically a maker platform where you can come in, you can build your augmented reality experiences. So upload your beautiful products. So obviously this is a UAV that they sell. You can add annotations to it, video, animation, audio, hot points, and you can really enrich the product experience. And then once you've finished building it in the platform, you can then deploy it out to all your customers globally using Google AR Core and Apple AR Kit. You might have heard about that recently in the press. And so that's basically the basis of our platform. So what we've really done is we've consolidated that entire product life cycle into one touch point, being a smartphone. So through your device now, you can activate your audience. You can get them browsing and interacting with your products in a whole new way. You can enable them to interact with the product and lift the lid on it, see the technology inside of it, understand how it works, and then customize it to your needs. Obviously, personalization is a massive trend. You then can purchase it. We're doing integrations with Shopify at the moment, and then obviously get help and support, and I'll show you some examples of that in a second. So how does it look? This is one of the examples we just did with Smart Cities in Christchurch that launched. Can you guys just... So this is basically enabling them to get better stakeholder engagement around all the exciting new projects that are going on in Christchurch at the moment. So this is bringing the new library to life and visualizing what it looks like. So a little demo of that. So it's a 3D city, and you can tap in, you can spin it around, you can tap on key aspects of the city, such as the new library. This was actually featured on TVNZ on Monday. I'm not sure if anybody saw it, so it's quite exciting. New flying car, and then we'll just tap into one of the buildings. And then yeah, so you can augment the library. You can see what the library is going to look like before it's been completed by tapping on annotations and hot points. So that's pretty cool. Cool. Just next slide. This one's another company who they manufacture beautiful chairs. So they're using our platform to virtually put our chairs into the client's environment. So see what it looks like in context, like IKEA have done. You can put it into your boardroom, you can see what it looks like. It looks pretty much as realistic as a physical product, and then you can change out and can configure it to your needs. So it's another really nice little example of some of the exciting stuff we're doing. Saab, as I mentioned earlier on, like Henry mentioned, it's hard to take large physical products overseas. You can't take a missile into the Prime Minister's office. You won't get that through the door. But with the power of augmented reality, you can take these products into a situation, and you can get the Prime Minister and all the defence chiefs to be able to see what these products look like in a situation, and it'll help them understand the value proposition of the product. So that's a really nice little example as well. Fisher and Paykel, so we've just recently worked with them. Again, they've got the manufacturing line here. They're selling this new product, Cosmo line, and so they're going to Germany. They can't take their 20-ton production line over to Germany physically, so using the power of augmented reality, we put it into a situation, we then enable customers to be able to tap on it and bring up all the data associated to that, all the sensors based on it. So I guess it harks back to some of the previous presentations on how you can create new products and services around your physical product. And then purchase, obviously, this is a retailer where we enable them to virtually put cushions into the Hilton Hotel in Tahiti, where the purchasing officer could see these cushions in situation and make a more informed purchasing decision. Off the back of this, they sold $25,000 worth of cushions within the first month alone by being able to solve that visualization issue. So it's really endless ways of applying the technology. And then moving forward, support as well. So I guess empowering people. So Tim Cook, I'll mention this in a second, is a huge advocate of AR and believes it has the ability to amplify human performance. And so this is working with Telstra and ISGM, where you can basically show somebody how to set up and troubleshoot on a modem. So how to do a technical task in a simple way. And then some work with Nespresso. So obviously we all get new products and we struggle with how to put them together, how they work. We struggle with troubleshooting. So what we've done is build a step-by-step guide where you can basically augment the product into your own environment, and then you can customize it to your needs and requirements, and you can run through a troubleshooting guide of step-by-step of how to descale your coffee machine, etc. So that's a really nice little example of how that works. So what are some of the opportunities? This is called the reality spectrum. I guess at one end of the spectrum we've got augmented reality. The other end of the spectrum we've got virtual reality. In the middle we've got mixed. And so we operate across that whole spectrum with Platter. We've built products that service the needs across the end-to-end life cycle. I guess some of the main user cases obviously around augmented reality. Sorry, can you guys just play that? Visualization, so as I showed earlier on. So this is creating some of the jobs of tomorrow. So product designers, 3D modelers, UX specialists. So these are some of the opportunities that have been created. So you can configure it in real time. Then you've got mixed reality. So basically this is putting large scale items into an environment, having hands-free so you can interact with it. You can change out entire environments. So again, these are creating new business models around interior design. Bring an engine into an environment. It's hard to bring a $20 million engine physically somewhere. So you can do that with mixed reality. And then through into virtual reality, Henry obviously covered this off. So putting people in virtual environments that might have a level of risk associated with them, where you can try and make a mistake in there and not have to worry about getting any injury or damage to yourself personally. So I guess there's massive opportunities right across the product lifecycle with manufacturing. Augmented reality is enabling technology. It's enabling us to design, prototype, train, recruit, streamline operations in a whole new way. It's empowering us to do all of that, and so that's some of the, I guess, the stuff that I'm excited by, and that's what makes my job fantastic. Is I'm creating these new, creating new opportunities to people. Creating new opportunities for people to create this content and deliver it in a whole new and exciting and engaging way. So that's what we're doing. So yeah, this year, basically by the end of the year, it's going to be on 1.8 billion devices, thanks to Apple ARKit and Google AR Core. So it's here. Customers are ready to use it. It solves a problem, and it has, as I mentioned earlier on, the ability to amplify human performance. So it'll unlock new possibilities for us to do things we might not have been able to do prior. So that's why we're really excited. So that's a little bit about us, and thanks for your time. Cheers.
Oh, thank you very much indeed, Rupert. There's some terrific stuff to follow up with you on that in due course, and I can imagine some connectivity going on around the table here. So over to you, Gareth. Thanks very much indeed.
Wonderful, thanks. Well, thanks all for coming here this morning. I'd like to introduce myself again. I'm Gareth Beckerman, and I'm the Technical Manager for an Auckland-based company called Revolution Fibres. Now, before I start talking about what I do for a living, I thought I'd just tell you a little bit about our company. Now, Revolution Fibres is an advanced materials manufacturer, and we specialise in producing materials known as nanofibre. So nanofibres themselves are basically a platform technology where lots of ingenious materials can be added into them, and we specialise in basically upscaling the technology and producing it to a level where it can actually be taken out into industry and used in the real world. So the process that our technology is based on is called electrospinning. Now, this is an ingenious method of producing submicron fibres, and essentially involves dissolving a polymer of any sort into a solvent, producing a droplet, and introducing that droplet into a high voltage electrostatic field. What happens is the droplet will spin around, and as it does so, it elongates and gets much thinner and lands on a collector plate. So the company started in 2009, and since then we have taken the technology from essentially a bench scale electrospinning machine all the way up to a very large full scale production machine which can electrospin 2 meters wide and literally thousands of meters in length. Now, this is quite unique because most electrospinners are very small scale, and the technology has been around for a long time, but no one has really taken it to the level where it can be taken out into the marketplace and used practically. So we have actually developed our own unique electrospinning method in-house, which we upscaled, and as I mentioned before, we're able to produce rolled goods now, as opposed to small samples that can't really be used for any practical applications. So getting back to what it is we make, so nanofibres, as the name implies, are extremely small fibres. Now, the fibres themselves are typically about 500 times thinner than human hair, extremely small. We can see this image over here, that's a human hair. Those are the nanofibres themselves. So they have an extremely high surface area and very, very small pore size. And we can actually make a wide range of different polymers into nanofibre form. So nanofibre itself is not really a product that you can just sell off the shelf. No one goes into the shop wanting to buy nanofibres. So what we've had to do is basically take the technology and customize it for a range of different applications. So nanofibres can be used for wound dressings, they can be used for batteries, air filtration, composite toughening, solar cells, and acoustics. And there's so many different applications that we can use nanofibre for. In fact, the technology is actually a fantastic one because we can incorporate all the latest high-tech materials into a form where it can actually be used. So we can include graphene, carbon nanotubes, aerogels, metal organic frameworks, molecularly imprinted polymers, all sorts of very high-tech nanoparticles that that are normally a little bit dangerous to use by themselves, we can actually incorporate these into a material where it's a lot safer and a lot more usable. So as a company, what we've had to do is basically produce a few nanofiber products. And I'll just go through them very briefly. So we have our CETA brand, which is for air filtration. We use our nanofibers in the HRV box filters that many of you probably use in your homes. We've got Xanthulay, which is a nanofiber used for toughening carbon fiber composites. Phonics, which is a sound deadening nanofiber for improving the acoustic performance of virtually anything that you need to absorb sound. Active Layer, which is a cosmetic nanofiber, which you may have seen a segment on News Hub on Monday night or The Breakfast Show on TV1 on Tuesday morning, demonstrating Active Layer, which is a nanofiber made from collagen nanofibers, which can be used to transfer active ingredients deep into the skin. We also have NanoDream, which is a dust mite proof pillowcase lining. So now that I've explained what the company does, I'll get back to my role. Now, being the technical manager in a small company often means that you have to wear a number of different hats, which makes the role extremely exciting and varied. So one of the duties I have as technical manager is business development. Very often the best person to promote the technology is the person who's invented it themselves. I do a lot of project management, both internally and for customers as well. As I mentioned before, our technology does need to be customized for various applications. So a lot of the work that I do is manage development projects and customization for customers. I provide technical support to customers because not many people know much about nanotechnology and nanofiber, so technical support is a key part of my job, as well as technical sales. And certainly one of the more enjoyable parts of my job is getting in the lab, rolling up the sleeves and performing R&D. So actually doing a bit of lab work and experimentation. And over the years, I have had the opportunity to develop some really amazing new products and concepts. And being part of a small company as well, we don't have all the expertise ourselves. And so we do collaborate with a lot of external research institutes and other companies and universities as well. So how did I get to the role where I am? So I took the academic route and did a PhD at the University of Waikato, which I thoroughly enjoyed. And certainly afterwards, as many students do, they go overseas and do an OE. And I chose to go to the UK for 3 years and worked in the aerospace industry there and gained some skills that I normally wouldn't have gathered if I'd have stayed here at home. So I came back to New Zealand and worked in the manufacturing industry, and essentially I had the right mix of education and real world skills to get the role at Revolution Fibers. So one of the questions that I'm often asked is what sort of skills and attributes are needed by a high-tech manufacturing industry. I won't spend a lot of time talking about this, and we will discuss this a little bit later on, but I thought I'd just mention a few points while I'm here. So certainly working in a high-tech industry, probably the most important thing is to have a can-do attitude. Because life is full of challenges, we do need the skills to overcome these challenges and not to get bogged down by them, but to have the right sort of mentality to keep going and to solve those problems. So problem-solving skills is also critical, as well as critical thinking. Hard work, nobody ever got anywhere without hard work, and certainly one thing that I've learned is you can have an amazing technology, but it's a pretty hard slog to actually make it a reality and to actually make a success of it. Certainly in high-tech industries, it certainly helps to have a scientific and engineering background. And one thing we've found is that having sales skills is very important as well. It's one thing having the nous, but if you can't get out there and sell yourself and your ideas, then really your ideas don't go anywhere. So it's quite important to have those skills to be able to get your ideas out and get them noticed. Certainly it's very important to have a learning capabilities. Our world is forever changing, it's very dynamic, and you do need to be able to adapt with the times and to retrain and learn new skills along the way. And it's very important to have practical skills and knowledge. It's one thing having the skills, you know, having the book learning and that, but to actually turn those ideas into reality, you often have to have practical skills to match. And also have good written and oral communication skills. Otherwise, no one really takes you seriously. So I guess the question is, which I think we'll get into a little bit later, is how does the industry attract creative talent and people with these sorts of skills? That's always the challenge for most manufacturers. Anyway, thanks for your time, and I'll pass it back to Rod.
Yeah, thank you very much indeed, Gareth. That's a terrific journey you've been on. And now it's great to hear from Jack, who's a much earlier stage in careers than you guys. So I'm a very big hand for Jack, because he's on a great journey too. Thank you very much indeed.
Hi, I'm Jack, and I'm a trainee engineer with Sutton Tools in Kaipoi. First off today, I'll tell you a bit about myself, then about where I work, and finally about the machines we build. So, a bit about me. I've always been pretty interested in engineering. So from a reasonably young age, I was pretty sure I'd end up doing some sort of engineering as a job. So after I finished high school, I went to UC to study engineering. And after completing the first year, I decided to get some experience in the field to give context to what I'd learned at UC. So early this year, I began looking for a job opportunity where I could get some practical experience in engineering. After searching for a while, my dad, who's also an engineer, suggested asking Sutton Tools in Kaipoi if they had any openings. After a few phone calls and a visit to the workshop, I began my job at Sutton Tools. And I'm currently building a strong foundation of skills and techniques from a skilled team of engineers. So Sutton Tools in Kaipoi is primarily a drill manufacturer. So in the workshop, we're constantly looking for ways to improve this process. The flute clearance point machines, or FCPs for short, and oil presses are our main ways of doing this. The FCP is a standalone drill making machine, and the oil press recycles oil. So, drill manufacturers use a lot of oil. Some is able to be recycled, but a large portion is unable to be recovered, left in a sludge of metal filings. Companies must pay to dispose of the sludge, as well as purchase more oil to compensate for the waste. The oil press takes the sludge and presses it, yielding a puck of metal filings and clean, reusable oil. In addition to the oil retrieved, the puck can be sold for profit. The presses are reliable, with the prototype machine has been constantly running at Sutton Tools for the past 14 years. My focus, though, is on the FCPs, which are standalone CNC drill making machines. Before I can talk about them, you'll need to know a bit about drills. So, the FCP must form all parts of the drill accurately and efficiently. The following are a few basic drill elements. The flutes are the helical grooves running the length of the drill. They allow swarf and debris to exit the hole being drilled. The bodies are the bits of material left between the flutes. The clearance is the recessed area along the bodies, which reduces friction while drilling. The remaining strip of material left unground by the clearance is called the margin. The chisel is the meeting of the bodies at the point. The cutting edge is the sharp front edge of the body that actually does the digging out of the hole being drilled. And finally, the heel is the curved back edge of the body. So, the FCPs create a ready-to-use drill from a hardened steel drill blank pictured in the top right. Firstly, an operator loads drill blanks into a hopper or magazine. The hopper is able to hold enough drill blanks to last the FCP all day. For a 3mm size, this is well over 1,000 drills. The FCP will then load a blank into one of 4 collets, which will take it to each grinding station. The first grind will form the flutes. Next, the clearance is ground across most of the width of the bodies, with the remaining unground material being the margin. And the last grind will form the point, which creates the cutting edges, chisel and point reliefs. Finally, the drill is ejected into a catch tray, ready for use. The FCP is fast, able to produce a drill every 20 seconds and requires no direct supervision after it's been set up. The FCP makes a wide range of sizes. This is from 0.8mm all the way up to 6mm. Changing the drill size is fast and straightforward compared to more traditional machines. And an automated dressing system shapes and maintains the grinding wheels on the fly, ensuring that all the drills in the run are made exactly the same. Full control and machine data, such as tool count, current grinding wheel diameter, and cycle time are all available through the web, allowing for the FCP to run largely unmanned. The FCP has 8 axes, which are all controlled very accurately through the software, allowing dimension changes as small as 0.001mm. A full setup guide and troubleshooting system are available to operators, making the FCP straightforward to set up and run. Clever engineering and cutting-edge technology allow these capabilities to be packaged in a compact machine with a small footprint and simple user interface. Now I'll show you guys a video of it running, give you some context. So here it is. This particular machine has a magazine rather than a hopper. It's a control panel. Here with some covers off, you can see the fluting wheel there. And the diamond wheel, which is the fluting dresser. Here's a shot from the back door. There's a clearance wheel in there. And the point way down there. Here it is indexing. That'll take each blank to a different grinding station. Here's a video of it running. So there it's doing the flute and the clearance simultaneously in the top station and the far station. You can see the point unit lifting there. It's then doing the point. The loader moving forwards. The collet will grasp the blank in the loader while doing the point there. Here it is ejecting. Finally, we have the machine automatically dressing, maintaining the clearance wheel there. Thanks for watching.
Thanks, Jack. It was great to see what you get up to. I am going to come straight back to you in a moment. Can I just ask for some tech help here, please, with the iPad? Could somebody reset this for the questions for me? Thanks. If somebody could pop up and do that. Thank you. It was triple locked to stop me mucking it up. Thanks very much, Carla. 3 very diverse technologies and careers. Rather than try and elevate to some themes, I'd like to just drill down. Sorry, I did not mean that pun at all. To some particular aspects of this. And Jack, having completed your engineering degree,
I'd just done the first year.
Just done the first year.
Yeah. And so I can come back to it probably after I do an apprenticeship with Sutton Tools.
Yes, but what was it that had you at the end of the first year going, this is fine, but I kind of want to get my hands on some stuff.
Yeah, exactly. It was just like that. I had enough of being in a classroom and not really knowing what I was learning, like where it could be applied. So I decided to get some actual practical experience to apply it and give me some context to what I've learned. And yeah, I'd be happy to come back after getting some context and completing that degree. Yeah.
Are you at a stage? How long have you been with Sutton?
Oh, a few months now.
Right, and are they starting to go, this is a guy who learns fast, and so they're putting you onto some actual projects, or are you still, thanks Carla, are you still basically getting your head and hands around a complex set of machinery there?
Yeah, I'm trying my best to learn as much as I can, so hopefully I can give them something back and actually apply some of these skills to something they could use. But at the moment I'm mostly just gathering good skills and information, which I can use later on.
On one hand, there's a very physical process going on there, but there's a great deal of data going on as well.
Yeah.
So do you, what's your sense as to where you're going to go as an engineer, whether it's going to be in actual the physical activity, and a lot of data driving it, or whether you might dive deeper and deeper down into the data?
I'd like to do a bit of both, but I think mainly it will be, I'd like doing the physical thing. I really like getting my hands dirty, getting hands-on with the machines themselves. But yeah, I would like to learn a bit of the programming and whatnot associated with the software and all that. Yeah.
Because of the great range of expertise here, I think there's the first bridge, because I think I'm trying to eventually bridge to Rupert. But the first bridge is that, Gareth, you've developed a very complex bit of machinery to be able to create those nanofibers in that continuous rolled product. So that's been your baby, is it?
Well, I can't actually take all the credit for that, because we did actually start the company with a few engineers that actually took the technology from lab scale to the factory. And certainly my role has been to develop products using those machines. And certainly we do have ongoing improvements. We do have a team of engineers that do actually make improvements, and we certainly have increased production rates dramatically over the last few years. And we've taken two approaches. One is improving the machine, and one is improving the chemistry and the formulations that we use on the machine. So by combining the two, combining engineering skills with chemistry, we've been able to make dramatic improvements and continue to do so.
And that's been very much an in-house expertise in terms of developing that machine, or you've actually been able to draw on a wide variety of expertise and vendors and consultants and the rest to help you do that?
Yes, that's all been done in-house with our own employees. We have a range of skills that we have amongst the team, which has enabled us to do that. So yeah, certainly we have spent a lot of time basically trying to improve our processes. And of course, we can't really involve too many external collaborators with regards to that, because a lot of our intellectual property is in the process itself. So we have kept it in-house, but at the same time we have kept an ear to the ground as to finding out what other developments are in the rest of the world. And I can honestly say that we're quite fortunate that we back the right horse in terms of the technology that we use. There are a number of different methods of producing nanofibers, and the process that we decided on right in the beginning has turned out to be the best.
Oh, so you backed, there were various contenders there. You backed a winner that wasn't necessarily the clear winner at the time, but you made the right choice.
That's correct, yes.
Yeah, that's quite fascinating. How many patents do you have pending?
Well, a lot of the technology is just trade secrets, because you can take out a patent, but you're telling the rest of the world exactly how you're doing things. Yeah. And certainly in manufacturing, it's very hard to police that patent. Certainly you can't really reverse engineer a nanofiber material and find out exactly how it was made.
Yes.
And then trace it back to your patent. So certainly the approach that we've taken is to keep our technology as a trade secret, and basically, yeah, we have a closed door policy in terms of our technology.
When you started off your career, sort of post PhD, did you expect to get so deeply involved in the actual machinery of how something was made, or is that an area of your career that has been developing in recent years?
Well, I come from a pretty unique background in the sense that I'm sort of half engineer, half scientist. So part of me does want to make the machines, and part of me wants to use those machines to make products out of them. So I guess it was always part of my dream to be involved in not only making and improving machines, but to utilize them as well.
And do you think that's a unique opportunity in New Zealand where you're able to combine the two? I always think of one of our great strengths in New Zealand is people are expert generalists rather than deep specialists. So I'm not belittling your deep knowledge, but the fact you're across a lot of aspects, obviously even down to sales as well, that gives you a richness of career here, and those elements sort of reinforcing and contributing to each other to give you a sort of a richer experience than you might in a bigger company overseas, where you're far more siloed, you're far more focused on an aspect of the job.
Well, personally, I really think it's a strength of New Zealand in the sense that a lot of engineers, be they manufacturers or R&D engineers, have quite a broad range of skills, and it makes it very easy to specialise once you have that broad foundation. And certainly a lot of the universities here in New Zealand these days are focusing a lot on not only the academic side, but also the practical aspects of the education. So they are teaching practical engineering as well. So certainly we're finding that a lot of graduates these days, can go into manufacturing quite seamlessly. So they've got both skills. And of course, it's very easy to diversify into a certain area and focus on one particular area, and certainly go further down the rabbit hole once you have that very good foundation.
Being male, I can only do one thing at a time, so I've been listening very hard to you and not really trying to work out how to now bridge to over here to, because it's the technology is quite dazzling.
Yeah. I think the bridge is basically, we need the skill sets of tomorrow, like what these guys are producing from CAD files is obviously a big part of our workflow. And it's because we're creating this, I guess, a whole new category where there's a real knowledge gap right now that we're finding, and that's around people that understand, I guess, what augmented reality is, how it works, how it fits into organisations like your business. That can talk between the product side as well as the marketing and sales side that obviously some of the other presenters mentioned earlier on. So that's where we need to get people, I guess, trained up and skilled up on not only how to create these amazing products and 3D models, but also how to translate them into a customer-centric view. And so that's kind of, I guess, hopefully bridging.
Yeah. So actually, you've got the CAD files in common, because you've got CAD files.
Yeah.
Yeah. So there you go.
Manufacturers start with that.
That was the answer. It's all in the CAD files.
Yeah.
But it was the point that David was making earlier in his first presentation. Oh, well, we were doing that kind of stuff back in the 90s and early 2000s. It's just massively moved on. And I was just completely fascinated. I mean, that's literally a sort of a build your own augmented reality platform.
Yep.
Perhaps I should do that for my journalism, and I'll have to talk to you about that later.
Yeah, no, definitely.
That's great. But there's still would you say there's still a very strong sort of engineering and systems thinking about what you're doing that actually also relates strongly back to Jack and to Gareth?
Yeah, there is. Yep. So it's we need to understand the workflow that they go through to be able to then translate that into an experience that's easily I guess, understood and broken apart from a visualization aspect. So take the Fisher and Paykel example I showed earlier on. We need to understand how that whole process, how they create that product to then break it apart and rebuild it for augmented reality and virtual reality view, because we can't use a 5 gigabyte file. It has to be a 20 meg file that's available on a mobile device, and so we can't use these very rich and large, I guess, BIM models and CAD files as they stand. And so, yeah, that's a real challenge for us, as I mentioned earlier on, is translating that information into a way that we can actually use it and absorb it and then visualize it. So, yeah, it's a big part of what we have to do. Yeah.
Thank you. Just a request, both online people watching the webcast and in the room, please do feed me with questions. I've got some, but I'm keen to get some more. And if I may just pick up one last thing with you, it sounds as though in your career that whilst that's an amazing leap from the Hell pizza box to the Saab missile,
yeah.
I think
Random
that's some sort of continuum. Basically, you've just been riding that technological wave. So what you were doing was, you thought it was pretty cool at the time.
Well, yeah, it was gimmicky at the time when AR first came out, and so then we had to look at what the real utility for augmented reality was, and that's around visualization, empowerment, training. You know, some of the examples we showed earlier on, moving large physical products into virtual spaces. And so, yeah, we were bleeding edge, and now in the last year, Facebook, Apple, Google, Microsoft have come and said, hey, the future of our roadmaps are based around augmented reality, and so it's happy days, because we were battling away for over 12 years in the space.
And they kind of blew out the water.
And now they've come in, and so it's completely changed our business model and, you know, enabled us to do these amazing things that you've seen on the screen, so, yeah.
Whereas in your case, Gareth, your PhD would of course be very focused on research and the thesis and all around that. But your career, whether it's been off in the UK doing aerospace or coming back to these roles in New Zealand, has taken, there is a clear trajectory there, but it's not kind of just like riding one technology. You've been stepping stone your way through things.
It's quite right. Certainly, you know, at a university, what they do is teach you how to learn. So the projects that you're involved with at the university don't necessarily dictate the path that you're going to take afterwards. And certainly, I've always followed my dreams in that, worked in areas that were of personal interest to me. And certainly with the changing world that we live in, when I started studying, there wasn't really much electrospinning or nanofiber production in the world, so that wasn't really on my list of career choices. And as it turned out, when the opportunity was there, I thought that that would be something that I'd really enjoy doing. And certainly I think I have probably one of the best jobs in the world, where I get to work with the most high-tech materials using one of the most high-tech processes, making some very unique products that all have very unique applications in the world.
How does this sound to you, Jack, in terms of you, as you sort of see some sort of a future ahead, what sort of themes are you picking up here for yourself, looking at what these two chaps have been up to?
Oh, well, it's a... Sorry, I just got a mind blank.
No, that's quite right. But I mean, I think that's one of the challenges of all this, because the opportunities are so enormous. It's trying to find the way through it. There was an American philosopher, Joseph Campbell, who talked about follow your bliss. Just follow the thing you love more than anything else, because that's going to give you the greatest satisfaction. So amidst all of these choices, the wonderful thing today is you can do that. And
totally,
yeah. And so how virtual you get in due course with your engineering degree and work will be great to see. Yeah. A couple of questions. Sue's asking us here, do we have any tips or tricks for how to think creatively?
I guess from my perspective, it's also getting out, outside of the ride, I call it. So get too embedded on your day-to-day job. And what I like to do is just get completely out of what I do. I go to an art gallery, go into nature, get lost basically, and that way it gives perspective on what I do. So that's one thing I do, is just get back to my I guess my core values of what drives me and what I'm passionate about, and that's normally skiing and snowboarding and surfing and mountain biking, and that way I then have that fresh perspective to come back and do a good job at I guess building a company and creating new products and keep on I guess that continuous innovation. Yeah.
Absolutely. It seems to me that Elon Musk tackles that by doing rockets for 1 hour and electric cars for another, and solar panels another hour. And here he even schedules his time with his children down to, it's... So there is a Kiwi way of doing things, which I think has some advantages. Creativity, any creativity of thinking, any tips?
Certainly in my field, I get my creativity from keeping up to date with the technologies. That's basically just looking at TED Talks and the technical TED Talks, scientific journals, trade magazines and things like that. And generally just talking with technically minded people, just to generate new ideas. So that's generally how I get my creativity.
Yeah.
No idea is a dumb idea. Just get started on something and keep refining it and building it. Pretty much that. Don't limit yourself. Get started on something you like. Yeah,
absolutely, no limits. And Gavin has a bit of creativity here. He wants an app where he can test the Saab missile against the Hell Pizza zombies to see who wins. Might be one possibility. Yeah, that's right. A question from James. Can you make a person more robotic when performing assembly while keeping the dexterity and thinking aspects of a person by using augmented reality? Are there examples? So in other words, does automation narrow us or our creativity, or is there a way that, for example, augmented reality can help us keep that, with that creativity, that inventiveness?
Yeah, that's a good question. I think it does empower us, as I showed you earlier on, like to do tasks you might not be able to do. Like the modem example is a good example of that. I'm sure we've all struggled with modems in the past or some form of technology. So if we can have that digital overlay that simplifies it for us in a step-by-step guide where you can be walked through what to do, that's a really great example of basically how it can empower us to do new tasks or be trained or learn in a whole new way. And then the creative aspect of that as well, I guess that's how you kind of translate the information. So how do you make it fun and engaging? How do you build gaming mechanics into it? So it's interesting with Hell Pizza Box, people think they're just playing a game, but what's actually happening is we're gamifying purchasing behaviour. So every time you bought a pizza, basically it would unlock another level. So we're making basically you buy more pizzas by using game mechanics while you're having fun. And so most people don't even know about that side of it. So that's a really good example of how creativity can then change our behaviour.
Yeah.
So hopefully that answers that question.
Yeah, and then the district health board gets in on its counter app.
Fair fighter.
Any augmented reality? Any takers over here on augmented reality?
I'll leave that to the experts.
Okay, right. Yeah. The very real reality is lunches here and downstairs. So can we give a very big hand to our panellists, please? Thank you.